and welcome to Alexander's Baking Show. Today, I'll be baking some chocolate chip cookies and explaining the details and chemistry along the way. Before any ingredients are prepared, it is important to know what those ingredients are and how you're going to measure them. This recipe calls for 9 reagents, or ingredients. Precision is important during baking to ensure all cookies turn out the same, thus how we measure out the ingredients is very important. Professional bakers do not use volumetric measurements like cups and teaspoons. Instead, they measure reagents like flour and sugar using mass, using a scale when possible, to make sure the precise amount of ingredient is present, just like in a lab. Regretfully, I do not possess a scale in my home, so I use classic volumetric measuring cups, which will introduce some imprecision into my baking. The first step is to mix the dries in a small bowl. I put 2 1/4 cups flour, 1 teaspoon of sodium bicarbonate, aka baking soda, and 1 teaspoon of iodized granular sodium chloride, salt. Sodium bicarbonate is the leavening agent in this recipe since at temperatures above 176 degrees Fahrenheit, 80 degrees Celsius, sodium bicarbonate starts to break down into 3 compounds, forming sodium carbonate, water, and carbon dioxide. At about 212 degrees Fahrenheit, the water in the dough turns into steam. The carbon dioxide gas and steam escape from the cookie and cause it to rise, making it fluffy and moist, and it's responsible for the bubbling seen during baking. The major components of wheat flour are protein, approximately 10 to 12%, and starch, approximately 70-75%. Glutenin and gliadin are 2 important proteins found in flour that combine together when wet and mixed to form gluten, which is formed from networks of these proteins that lengthen and strengthen through creation of interchain and intrachain disulfide bonds, which is why to avoid a tough cookie, you don't want to overmix the dough. Next, I softened the unsalted butter, which consists of 80% milk fat, 16% water, and 3% milk solids. It is crucial to heat the butter first so that it can melt and mix more evenly with the dough, so I put it in the microwave for 1.5 minutes and cut into it a few times to increase its surface area for phase transfer to be a liquid. Butter is an emulsion of polar H2O molecules and nonpolar lipids in the milk fat. An emulsion is a mixture of 2 more liquids that are normally immiscible. The negatively charged oxygen and positively charged non-symmetric hydrogens create that dipole that causes water to be polar, while the long non-polar carbon-carbon bonds of the hydrocarbon chains of the lipid molecule are what make it hydrophobic and non-polar. After adding the mostly melted butter to a large mixing bowl, I added 3/4 cups of granulated white sucrose crystals, white sugar, 3/4 cups sucrose molasses mixture, brown sugar, and 1 tablespoon of vanilla extract. The vanilla extract is a vanillin ethanol solution, so it evaporates and cooks down when heated, because the volatile ethanol volatilizes and escapes into the air. You want to add the vanilla as late as possible because it will evaporate and the taste will not be as strong. Vanillin is soluble in ethanol because both molecules are polar with their OH alcohol groups. Now comes the adding of the 2 eggs, which contain a lot of globular proteins such as ovalbumin, ovotransferrin, and ovomucoid. Egg white proteins contain both hydrophilic and hydrophobic amino acids. When the protein is curled up, the hydrophobic amino acids are packed in the center, away from the water, and the hydrophilic ones are on the outside, closer to the water. When you apply heat or beat the eggs by mixing the mixture, you agitate those proteins, slamming them into each other and breaking the weak bonds that kept the protein curled up. The egg proteins uncoil and form bonds with other uncurled egg proteins, forming a network of proteins similar to the gluten disulfide bond network. Many proteins in egg yolk can act as emulsifiers because they have some amino acids that repel water and some amino acids that attract water due to polar and nonpolar substituents. Lecithin is another important emulsifier, phospholipid, found in egg yolk with a hydrophilic head and a long hydrophobic tail. Now I slowly, incrementally add the dry ingredients into the eggy, buttery, sugary mixture while mixing until it was all added and homogenized. Homogenizing the mixture is important to make sure the cookies cook evenly and all ingredients are evenly distributed. I then added the entire bag of semi-sweet chocolate chips, which was 12 ounces according to the bag, trying to make them evenly distributed as well. Then I scooped roughly 2 tablespoons of dough at a time onto an ungreased baking sheet, with the knowledge that the dough would spread out as the butter melts during the baking. I put a few walnuts and coconut shavings on top of some of the cookies just for fun. The oven had been preheated to 375 degrees Fahrenheit, so it was ready to go now when I put the baking sheet with dough in for roughly 11 minutes. During the baking process, the butter begins to melt at around 92 degrees, causing the dough ball to spread out, so you can chill the dough prior to baking to slow down the spreading out, and thus create smaller cookies. As the water pulls away from the butter emulsion, it bubbles and is released from the cookie as more steam, leaving the lipids in the butter to coat and shorten the gluten in the dough to prevent it from making longer strands by creating a charged physical barrier between the gluten molecules. During this baking time, the gas forming reactions mentioned earlier occurred, which explains all the bubbling. One of the most important reactions, the Maillard reaction, also occurred. The Maillard reaction occurs around 310 degrees Fahrenheit between aldose sugars and amino acid proteins. The nucleophilic amino group of the amino acid proteins performs a backside attack of the electrophilic carbonyl group of the sugar, forming an N-substituted glycosylamine and water in a condensation reaction. More water is kicked off during an Amadori rearrangement, where intramolecular redox reactions convert this alpha hydroxyamine into an alpha ketoamine irreversibly. The alpha ketoamine Amadori products then undergo dehydration and deamination to produce many dicarbonyls, which can then produce Strecker aldehydes and other carbon backbone products. Every part of this reaction creates compounds which add to the flavor complexity of the baked good and changes the wavelength of absorption, adding to the signature browning effect. White granulated sugar is mostly sucrose, a disaccharide, so it doesn't participate as well in the Maillard reaction. Brown sugar contains glucose, which is an aldose, which is a monosaccharide with a carbon backbone chain with an aldehyde group and hydroxyl groups connected to all the other carbon atoms. That is why many recipes include both white and brown sugar molasses. At 365 degrees, caramelization also occurs, which is the pyrolysis of certain sugars at very high heat to create a wonderfully rich, nutty flavor. Caramelization does not occur at lower temperatures, so cookies baked at 350 or lower have a more mild flavor and color. Overall, I made 2 batches of cookies that I baked for about 11 minutes each. The wonderful aroma of the Maillard reaction products filled the kitchen toward the end of each baking cycle. Overall, I was very, very pleased with my results, as the cookies turned out soft yet firm, and were not burnt at all. This baking experience was lovely, and so was learning about the different principles behind baking such simple cookies. The procedure could have been improved by more precise measurements such as using mass scales, experimenting with different toppings like sea salt on top, and making sure to minimize the time between opening the baking door, putting in the dough, and closing the oven, as the temperature dropped from 375 to 320 within 10 seconds of the oven being open, which surely slowed down the baking process for the first batch of cookies. I was much more careful with the second batch, and they all come out looking and tasting lovely. Thank you for watching.